We are very much delighted to host this event and welcome you to the terrific lineup of speakers and discussants. Before proceeding with the details of our workshop, as co-organizers, we would like to extend our warmest gratitude to the Communication and Event Officer, Maddie Giles, for assisting us, and our program committee members, Brent Simpson, Anna Shepard, Clarita Gohani, Milena Svetkova, Nan Zhang, Ozan Aksoy, Uf Liebe, Wojtek Szepurka for their great support and help to make this event possible. We're also deeply indebted to Deli Baldassari for delivering our keynote lecture tomorrow, which I'm sure we are all already looking forward to. As we emphasize in our call for the workshop, the growing interest in causal explanations in social sciences has prompted many researchers to turn to experimental research designs to advance empirical knowledge over the last 2 decades. Even though sociologists have started being interested in experimental methods, including lab experiments, field experiments, survey and online experiments, more than ever, the bibliometric research shows that mainstream sociology is lagging behind other social science disciplines on featuring experimental research. Given that early career sociologists interested in experimental sociology may have difficulties finding a platform to discuss their research and receive constructive feedback outside their immediate network. Therefore, as 2 early career experimental sociologists, Sergio and myself, we decided to organize this online workshop to support mainly our early career colleagues. But it's important to acknowledge, prior to our initiative, the annual conference of experimental sociology, ACES, in Europe has been taking place since 2018, and the next ACES meeting will be happening this September. We also strongly encourage fellow social scientists to follow and participate in ACES events. Finally, before starting our first session, I would like to walk us through the ground rules, namely Zoom etiquette, throughout our workshop. First and foremost, please make sure that you keep yourself muted, not to distract the presentations with outside noises. We also kindly request not to interrupt speakers during their presentations. So please save your questions for the Q&A session. Each speaker will have 30 minutes for their presentation and a following discussion for 15 minutes by their discussant. After each study, we will have a 10-minute Q&A to ask your question. Please use the raise hand feature in Zoom. We will collect them accordingly. Again, thank you all for joining us today. I'll be chairing today's sessions. If you are ready to go, let's get started with our first session. I'm now happy to introduce our first presenter. She's among us, Anna Sokolova, who is a PhD student in social and behavioral sciences at the University of Mannheim. Her main interests center around economic and analytical sociology, social networks, trust, cooperation, experimental methods, and formal modeling. And today, Anna is going to present her cohort research entitled Cooperation in a Social Dilemma through Investments in Repeated Interactions and Contractual Agreements. Her presentation will follow a discussion by Ozan Aksoy. He's an associate professor in social science at Social Research Institute at University College London. Ozan's research mainly focuses on cooperation, trust, pro-social behavior, and political sociology of religion using lab experiments, natural experiments, observational data, and formal modeling. And his research has been published not only in leading sociology journals such as American Journal of Sociology, European Sociological Review, Social Forces, but also in numerous political science, social psychology, and game theory journals. I think now, with no more delay, the floor is yours, Anna.
So thank you very much. Thank you for organizing this event and for giving me an opportunity to present. The working paper I'm going to present is based on my master thesis written in Utrecht University under the supervision of Vincent, Buskens and Werner, Raub, my co-authors. And of course, I will be very happy to hear your feedback and questions on that. So the working paper is titled Cooperation for Investments in Repeated Interactions and Contractual Agreements, an Experimental Study. So we know that social dilemma situation can be characterized by the conflict between collective and individual rationality, that if everyone cooperates, each actor is better off than when everybody defects, but of course individuals have individual incentive to defect, and that leads to this conflict between collective and individual rationality. So we know from formal models and from empirical studies that repeated interactions as well as contractual agreements foster cooperation. We know that not just from sociological and psychological studies, but of course also, and I think most of all, from economics. And therefore, we come to the conclusion that rational actors then have incentives to invest information of these long-term relations that involve repeated interactions or in contractual agreements, of course, if they anticipate these positive effects of these mechanisms on cooperation. So models and experimental evidence that capture both the effects and the investments in repeated interactions and contractual agreements are rather scarce. So one theoretical model that I cite here is by my co-author Werner Raub. So our study is based on this theoretical model. And the new contribution that we bring hopefully to the field is that we capture this both theory and experimental test on effects as well as investments in contractual agreements and repeated interactions. So we present this kind of integrated analysis. So we employ the prisoner's dilemma. I will further refer to that either as prisoner's dilemma or just PD. I hope that's okay with everyone. So we employ PD as a canonical model for a social dilemma. Here you can see the formal representation of the prisoner's dilemma with payoffs as in our experiment already. So we know that in this one-shot prisoner's dilemma, defection is the dominant strategy for each actor, and mutual defection is then the unique equilibrium. But mutual defection is, of course, associated with a Pareto suboptimal outcome, and both actors are better off when they cooperate. And mutual cooperation is a Pareto optimal strategy combination. You can see that in italic faced cell right here on this formal representation, but it is not an equilibrium. So to analyze the effects of investments in repeated interactions and contractual agreements, we embed the prisoner's dilemma in more complex games gamma. So here I will present two more complex games gamma. Gamma repeat one shot that is designed to analyze repeated interactions, and Gamma Contract one shot. This game was designed to analyze investments in and effects of contractual agreements. I will now talk more about the extensive form of this game. So here you can also see this kind of schematic representation. I will hopefully leave this slide long enough so that everyone has time to grasp the extensive form of the game. I will also talk about it, of course. So games Gamma Repeat One Shot and games Contract One Shot are rather similar in structure. So both of them have two stages, stage 0 and stage 1. So first I will talk more in detail about Gamma Repeat One Shot. So in stage 1, an actor chooses between subsequently playing a one-shot prisoner's dilemma, and this choice will come for free for this actor, or they can choose to play an indefinitely repeated prisoner's dilemma, and this choice will come at costs for them. Then stage 1 comes after that, and according to the choice made in stage 0, this actor plays either a one-shot prisoner's dilemma or a repeated prisoner's dilemma with a partner who has made the same choice. So for example, in stage 0, an actor chooses to play a one-shot prisoner's dilemma in the next stage. They don't pay anything for that, and in stage 1 they play one-shot prisoner's dilemma with a partner who has made the same choice in the previous stage. So they're matched to the partner who has made the same choice. And Gamma Contract One Shot is of course a similar game, has a similar structure, but on stage 0, an actor chooses between playing a one-shot prisoner's dilemma, which again comes for free, and playing a prisoner's dilemma with contractual agreements that define fine and compensation. And this option comes at cost for this actor. And again, in stage 1, an actor plays either a one-shot prisoner's dilemma or a prisoner's dilemma with contractual agreements, again with a partner who has made the same choice. So now I will describe more these sub-games, PD repeat and PD contract. I will also use this abbreviation. So PD repeat is the indefinitely often repeated version of the prisoner's dilemma that was also presented in figure 1 of the previous slide, with continuation probability 0.75. So we calculate payoff as an average payoff for all rounds. We do that, of course, to compare it, to be able to compare it to PD contract. And PD repeat has an equilibrium such that actors cooperate through all rounds. And you can see the formal representation of PD contract on the right side of this table. So as I said earlier, this PD contract defines a fine and compensation. So fine is something that is subtracted from actor's payoff if he unilaterally defects, and then a compensation is awarded to the actor who got their trust abused. So as you can see, if one actor choose C, cooperation, and the other chooses defection, the one that chose defection gets fined, and of course the other actor gets compensated. But if they both choose C or D, their payoffs are not altered. Some characteristics that go for both of the subgames, PD repeat and PD contract, are that payoffs are defined as payoffs from stage 1 minus investment costs, if any, were bared from stage 0. So as I talked, in stage 0, you can choose to play an indefinitely repeated PD or a PD with contractual agreements at costs. So then your payoffs from stage 1 are the payoffs, sorry, the investment costs are subtracted from that payoff. And investment costs have 3 levels. So we introduce 3 levels of investment costs: low, medium, and high investment costs. So I will, of course, talk more in detail why we choose these 3 levels. But before I introduce the solutions to the games, I will briefly talk about our game theoretic assumptions. So we assume that games gamma are non-cooperative games with complete information and common knowledge of the extensive form of the games. We assume self-regarding preferences. We define equilibrium selection based on the solution of symmetric game and payoff dominance as the selection criterion. And we assume that actors play subgame perfect equilibrium. So applying backwards induction, and due to our game theoretic assumptions, we can imply certain solutions for games gamma. So for low and medium investment costs, games gamma have equilibria with investments in stage 0 and cooperation in stage 1. So then the solution of the game will be to invest in PD repeat or PD contract in stage 0 and then subsequently cooperate in stage 1. And for high investment costs, the equilibrium behavior in games gamma implies no investments in stage 0 and defection in stage 1. So the solution of the game would be not to invest in PD repeat or PD contract in stage 0 and then subsequently defect in a one-shot prisoner's dilemma in stage 1. So we introduced these 3 levels. So to simplify that, we have this high investment cost, which is above the threshold where actors are rationally ready to invest in this mechanism of cooperation, and low and medium costs are below that threshold. So why we introduce 2 levels below the threshold. So of course, if we were just to adopt this very strict game theoretic approach, we would only introduce 1 cost, which would be the low one. But of course, we try to bring our model a bit closer to real life, and we know that these expected payoffs, especially from PD repeat, can be a bit different from strict game theoretic predictions. That's why we also calculate loosely based on our own perceptions, of course. So it's kind of arbitrary, our perceptions, what would be the expected payoffs of conditional cooperators. So we define medium investment cost as something that would fit with strict game theoretic predictions, but that would be higher than payoffs from expected payoffs from cooperation. And low investment costs would then fit also these very strict game theoretic predictions, what people are willing to invest in mechanisms of cooperation. So that's why we introduced these two approaches to derive our hypothesis. So the first approach would be more fit to the strict game theoretic predictions. So likelihood of investments in stage 0 is higher when it is equilibrium behavior according to the solution than when it is not. And another approach is more a comparative statics approach, more based on behavioral game theory and less based on these strict game theoretic predictions that the conditions for equilibrium behavior are less restrictive, then the likelihood for investments in stage 0 is higher. And you can see here hypotheses. They're of course equivalent for gamma repeat one-shot and gamma contract one-shot. So you can see that our hypotheses H1A and H3A are about likelihood of investments in stage 0 of gamma repeat one-shot or gamma contract one-shot, that it is higher under low investment costs than under high investment costs. Then it is higher under medium investment costs than under high investment costs. And our third hypothesis is more fitting to this behavioral game theoretic approach, is that the likelihood of investment in stage 0 is higher under low investment costs than under medium investment costs. So what we do is we compare each of the level of investment cost. And we also have hypotheses about the effects of mechanisms of cooperation. This is, of course, the continuation of a previous research, so it's not a very novel contribution of our study, but of course we still test and derive this hypothesis that the likelihood of cooperation is higher in PD repeat and PD contract than in one-shot PD. So we'll also try hypothesis on the positive effects of these mechanisms of cooperation. So another thing that we can employ and that we do in our research is that we also compare preferences towards repeated interactions and contractual agreements. So that was another feature of our study. We designed PD repeat and PD contract as strategically equivalent, meaning that we designed our payoffs in our experiment that expected payoff from mutual cooperation is the same as the actor's payoff from mutual cooperation in both games. So from the payoff perspective, it doesn't matter whether you cooperate in PD repeat or you cooperate in PD contract. And of course, the same goes for defection. So from a strictly theoretic perspective, we could expect no difference in preferences between PD repeat and PD contract if there was a direct choice between them. But we know from Folk theorem that PD repeat has many more equilibria than PD contract, and that empirical studies show that not everyone cooperates in repeated prisoner's dilemmas, even when it's equilibrium behavior. So not all people cooperate in repeated prisoner's dilemma, and not all people defect in one-shot prisoner's dilemma. That brings more uncertainty to PD repeat compared to PD contract. So we create this kind of conjecture. Conjecture 1, that controlling for investment costs, the likelihood of investments in contractual agreements is higher than the likelihood of investments in repeated interactions, that in the situation of the direct choice between these two mechanisms, that contractual agreements would be preferred over repeated interactions. So now you can see the experimental timeline, the experimental design of our study. So the experiment comprised 5 parts. So the first part, of course, comprised just some questions for understanding how people perceive our games and do people understand the instructions. So first, participants played a one-shot prisoner's dilemma. They answered some control questions on PD repeat. They played the first round of PD repeat, and they also played a PD contract. So one-shot PD and PD contract were incentivized, but the payoffs were given at the end of the experiment to avoid the effects of these interactions on the subsequent play in the games of our interest. Then part 2 and part 3 employ this gamma repeat one-shot and gamma contract one-shot, and the experiment very closely resembles the extensive form of the game that I already talked about. So in part 2, a participant plays either gamma repeat one-shot or gamma contract one-shot. In the first iteration, at the stage 0, the participant chooses between PD repeat and a one-shot PD, and then place the chosen PD with a partner who has made the same choice. And that goes for the second iteration. In the second iteration, the participants made exactly the same choices. So first they choose between PD repeat and one-shot PD, then they play the chosen PD, and of course they choose between cooperation and defection with the partner they were matched to. So each gamma has 2 iterations. And then in part 3, a participant plays a game that he has not played before. So for example, if in part 2 a participant played gamma repeat one shot, in part 3 he or she will be playing gamma contract one shot. And to test our conjecture on preference between PD repeat and PD contract, we also introduced part 4, where participants play a very similar game, gamma repeat contract, where in the stage 0, participants choose between PD repeat and PD contract. Both of these mechanisms cost the same amount of points, the same amount of money to choose, and then they play the game of our choice with the partner who has made the same choice. And in part 5, they deal with social value orientation slider. They answer post-experimental questionnaire that comprise measures of tendency towards reciprocity, tendency towards risk, altruism, previous game theoretic experience, previous experience with participating in experiments, and then they receive their payment. And then, of course, comes the end of the experiment. So here is some information about the procedure and participants of our experiment, some statistics about our participant. So we had 187 participants in total. You might be surprised why we have an even number here. Of course, each session comprised the even number of participants. It's just that one participant dropped out of the experiment during the experiment, very close to the end. So we deleted the observations, the decisions made by this participant from the analysis, but of course here we have an even number, but that's not a deliberate mistake, of course. So we employ the between subject design. So we have 2 order conditions and 3 cost conditions. So 3 cost conditions are low costs, which is 5 points, then medium costs, which is 15 points, and high costs, 45 points. And then 2 order conditions are about whether a participant starts with gamma repeat one shot and then plays gamma contract one shot in part 3 or vice versa. So of course these 2 order conditions and 3 investment cost conditions make up for 6 conditions in total. So this experiment was held in the laboratory of Utrecht University. The analytical strategy that we employed to test our hypothesis is multi-level logistic regression models. So to account for the structure of the data, we introduced 3 levels. So decisions are nested in participants, and participants are in turn nested in sessions. To account for the multi-level structure of the data and for their repeated decisions made on investments, we introduce a random intercept on a participant level, and we introduce some measures of control for previous experience, namely control for previous investment decisions and previous earnings made throughout the experiment. And for robustness analysis, we control for demographic characteristics, social value orientations, experience and session characteristics. And we also do the analysis separately on decisions made only in part 2 of the experiment and only in iteration 1 of part 2 to have this claim measure without any previous experience. So I will now go to the results. So first we can see descriptive overview of the investment decisions in repeated interactions and contractual agreements made in parts 2 and 3 of the experiment. So here you can see a rather clear pattern, which is holds for most of the parts and for both of the mechanisms. So we can see that most of the investment decisions are in for low costs, and we see less decisions to invest in these mechanisms of cooperation under medium costs, and of course the least amount of decisions to actually invest in these mechanisms of cooperation are under high costs. Now I will show you the result of our regression analysis. So this is these are the core results from our regression models. This table comprises regression models for repeated directions and for contractual agreements. So of course we have these investment costs variables as independent variables here, and in these regression models we controlled for part, previous earnings and previous investments in PD repeat and PD contract, but here I just show the core results. So we can see that for repeated interactions, our hypothesis H1A supported that high investment costs lead to less investments in repeated interactions. Hypothesis H1B supported as well. We see the significant difference between high and medium cost conditions. So under high cost condition, people invest less in repeated interactions than under medium costs, but we don't see any support for hypothesis H1C. So there is basically no difference between low and medium costs. If you either have to pay 5 or 15 points, it doesn't matter whether you decide to invest in repeated interactions or not. But for contractual agreements, we find support for all three of our hypotheses. So we see a significant difference between high and medium costs and between medium and low costs. So of course, under low cost, most investment decisions take place. Then under medium investment costs, there are less investment decisions, and under high investment costs, there are the least amount of decisions to invest in contractual agreements. So we introduce two ways to test the preferences between repeated interactions and contractual agreements. So this is the direct comparison. So in part 4 of our experiment, participants had to choose directly between repeated interactions and contractual agreements. So we can look here at in the baseline model, adjust the constant, as it defines the direction of our effect, and we see that indeed contractual agreements are preferred over repeated interactions, and we only have a very small effect of previous earnings from contractual agreements in parts 2 and 3 on these decisions. So indeed, for direct comparison, our conjecture 1 that contractual agreements are preferred over repeated interactions is supported. But we also employ another method to test, so another approach to test this preference of repeated interactions and contractual agreements. So this is kind of indirect comparison. So we test the decisions made in parts 2 and 3. So these are not direct comparison decisions. So people had to choose between repeated interactions and one-shot business dilemma, and between contractual agreements and one-shot business dilemma. So we test it indirectly. But we see that since our conjecture was about all cost levels, that contractual agreements will be preferred over repeated interactions, we don't see the support for this conjecture for our indirect comparison of this conjecture. So we see that probabilities to invest in PD repeat are not strongly less than probabilities to invest in PD contract. There is a very equivocal pattern here, so we cannot claim that our conjecture 1 finds support in our data for this indirect comparison approach. So in general, we find a rather equivocal support for this conjecture. So then I move to the results that refer to the effects on cooperation. So effects of repeated interactions and effects of contractual agreements on cooperation. So here our dependent variable would be the decision to either cooperate on the effect in the first round. So when we have the indefinitely repeated business dilemma, we only deal with the decision made in the first round of that subgame. So we control for investment cost condition and interaction between investment cost condition and decision to invest in PD repeat and PD contract, and we find a strong support for our hypothesis H2 and H4. So of course, in line with previous research, we see that both repeated interactions and contractual agreements indeed foster cooperation, and we also see that contractual agreements actually have stronger effect on cooperation than repeated interactions do, which is also in line with previous research. So I will now move to the section of conclusion and discussion. So first I will quickly summarize our results. So we investigated both investments in and effects of two mechanisms of cooperation, repeated interactions and contractual agreements. So we find this, we try to establish this close connection between game theoretic modeling and experimental work, but we also try to introduce this more behavioral game theoretic approach, a bit more far away from very strict game theoretic modeling. And we also see that this approach that is closer to behavioral add-ons on game theory works actually worse than these strict standard game theoretic assumptions and strict game theoretic predictions. So while we, of course, replicate earlier evidence that both repeated interactions and contractual agreements are good for cooperation, that they foster cooperation in social dilemma situations, we also find quite some support for hypotheses on investments, that people anticipate the positive effects of these mechanisms of cooperation and that they're willing to invest in establishing these mechanisms if they see that the positive consequences of establishing this mechanism outweigh the costs that individuals have to bear to do that. So what was the purpose? The underlying research strategy behind our research is to take this very strict game theoretic approach and to bring it to the analysis of the emergence of social structures and social organizations. And as examples of social organization, we here employed repeated interactions and contractual agreements as mechanisms of cooperation. And of course, we model the establishment of social structures themselves as well as their result. And some suggestions for further research. So first of all, in this research, in this paper, we varied the level, the cost level, so the investment cost level, but there are also opportunities to vary, for example, the continuation probability of the game, so that people can anticipate different outcomes of that mechanism of cooperation. This is a bit less obvious for participants, so we try to vary the parameter which is most obvious for participants to observe. But of course, there is space to also vary other parameters of these game theoretic models. Then this model can also be adjusted for other types of social dilemmas and other mechanisms for cooperation. And another possible direction of further research is to investigate the effects of population heterogeneity on the formation of these mechanisms. So for example, when a certain group of people have more pre-existing resources to afford to invest in the establishment of this mechanisms of cooperation and to anticipate and to gain these benefits from them. So thank you very much for your attention, and I will be very happy to hear your feedback and your questions.
Thank you very much, Anna. It was a terrific presentation. So we are definitely on time. So it's actually good. We got probably a little bit more time for the Q&A after Ozan's discussion. So without further delay, so Ozan, the floor is yours. So thank you for the discussion.
Oh, sorry, I will stop sharing. Go first.
Yeah, I think we need to rearrange it.
Can you hear me well?
Yes, exactly. Okay.
I will now. And can you see my screen?
Exactly. All good, Ozan.
Perfect.
Thank you.
First, thanks to Burak and Sergio for organizing this. It's really refreshing to see so many kindred spirits in one place. We are now more than 50, and this is rather rare in all other conferences that I attend. So we are in good company here. So thanks for Burak and Sergio again. And my task is obviously to discuss Anna's paper, which is with Vincent and Werner. This is a very well developed paper. It's written well, and there are many strengths. So there are many things to like with this paper. For example, the predictions, the paper is based on a formal model. So it's well grounded in a theory. Nothing is, hand waving. Everything is based on this formal model. Assumptions behind hypotheses are rather clear. So there's this classical game theoretic rationality assumption, payoffs equal to own money assumption, Pareto dominance, which is a tricky but nonetheless necessary assumption for the predictions, and symmetry. So if the two players are involved, then they would play the symmetric equilibrium. So all these assumptions are rather clear, which is a strength. And what I also liked is that the links with broader sociological debates were rather clear. It is difficult to establish these links in experimental work with more broader sociological debates, and I thought this was rather well made in the paper. The experimental design is sound, it's very well explained, and the text is written rather clearly, so it reads well. This is already a rather well developed paper, and it is close to publication, I thought. But as my role as a discussant, I had to, suggest for further improvement and maybe simulate some of the potentially evil reviewers' comments. So one thing that struck me when I was reading the paper is that these hypotheses 1C and 3C struck me as odd. So these hypotheses there were three conditions: low, medium, high investment conditions, and these hypotheses predict that there would be more investment into repeated game or contractual game if the investment costs are medium compared to low investment condition. Okay, so this prediction is not based on theory, your formal theory. In fact, your formal theory predicts the opposite. So it predicts that there should be no difference between low investment and medium investment conditions, because both of them fall into the prediction that people would select into repeated games or contractual PD. So it's not based in theory. It's not supported by data anyways. So I was missing the rationale behind why you formulated this hypothesis. I would formulate the opposite. So we predict no difference between this and that condition, rather than you seem to make the argument that by posing this hypothesis, you're testing the boundaries of classical game theory, that kind of argument. And I thought it was a kind of half-baked. And there's nothing more than a half-baked idea that entices evil reviewers to pick on. So if your aim is really to test the boundaries of classical game theory, then there are possibly better and more systematic ways of doing that. For example, you can look at point predictions, which you advise not to do, so you look at comparative statistics. You could also look at the effects of investment costs on cooperation. If you paid more to buy into the repeated games, does it make you cooperate more than if you haven't paid so much? The sunk cost fallacy could be tested in a very interesting way in this case. You could exploit individual heterogeneity. There are cooperators and less cooperators, and how do they differ? So there are more systematic, better ways of testing the boundaries of classical game theory, and this argument doesn't really justify these particular hypotheses. In terms of experimental design, there was something odd that also struck me. So, say this game is a kind of stage game. Okay, you first select whether you want to play the one-shot game or the repeated version or the contractual version. Then you select in each subgame what to do. But as far as I could understand from the experimental design, what happens is that if, say, someone selects the one-shot game, then one plays this game with all other people in the session who also self-selected into one-shot game. If one selects the repeated, side of the game tree, then one self-selects into the group of all actors who also self-selected into this repeated game. And this is different. This makes the game a different game than the one you analyze, okay? Because in classical, dynamic games, there is one game, you're playing this game with the same other person, and you have to devise, conditional strategies, what to do in this side of the tree, in that side of the tree, and then equilibrium is based on, best responses, when best responses match subgame perfect equilibrium. But here we are dealing with another thing, if you select this subgame, then you are playing with potentially a different pool of players than if you self-selected into that subgame. This difference between your design and game theoretic analysis may not make a difference under your model assumptions, because you're assuming perfect rationality, selfishness, etc., and everyone is homogeneous. So this difference may not make a difference theoretically, but in most realistic and most common setups, I think this may make a difference. If I am playing with a particular type of self-selected group, this may affect my behavior and in fact my decision to select which subgame to play with in the first place. There could be signaling issues. Oh, now I'm playing with a one-shot game with an actor who also chose to play in the one-shot game, okay? That could signal something about the other player. It can even tap into, psychological issues like group identity. So now I'm playing the game with all others who self-selected into the repeated game structure. And this complicates the game. And it wasn't clear why this type of design is selected rather than, the typical conditional strategy kind of design. So this would be something that reviewers might pick on when you submit this to a journal. And the final major issue or point or suggestion I thought is that I think the decision to which subgame to play and the decision to cooperate, these two decisions should be analyzed simultaneously, okay? Which at the moment is analyzed separately. So first you analyze who selects whether to play one-shot game versus repeated game, and then you analyze who cooperates. I mean, those who selected one-shot versus repeated game, where cooperation is higher. But there might be confounders that affect both of these decisions, okay? So there might be a correlation between the error terms, so to speak, in the statistical sense, between these two decisions. So there might be other variables that affect both. And these other variables could be the type of the player, okay? Certain type of players may self-select into repeated games more often, and that type of players may also be more cooperative, all right? But analyzing them separately and looking at just this association doesn't tell you that what you see, an increased cooperation, is due to the design, the game structure, or whatever. Yeah, it could be a spurious association, okay? So this could be addressed. And the way to address this, or how I would address this, would be using these investment costs that you manipulated in the experiment exogenously, using that as an instrument that affects, that predicts which side of the game tree one is playing, okay, the game tree decision behavior, and then exploiting this exogenous variation in the decision to which game tree to play as an instrument, and then predicting cooperation from that decision to self-select into. And in that case, you can explicitly model this correlation between the error terms, all right? That could be done, and in fact, this is a statistical model that could be fitted to your experimental data, because you have repeated observations within an individual, and you could exploit that better to address these kind of issues, I thought. And the final thing, for this instrumental variable setup to work, you need, this exclusion restriction criterion, namely, there should be no direct effect of investment costs on cooperation. The sunk cost fallacy that I mentioned initially. If you paid more to play the repeated game than you paid less, does it make you more cooperative because you have already invested more? Okay, that's something that shouldn't be happening within the strict game theoretic domain, but nonetheless could be there, and that could, violate this instrumental variable setup design. But in your case, I think your design allows you to test this link, okay? And the reason is you have, in fact, 2 decisions within person for each of these conditions. In fact, the full model would be an augmented version of this graph that I put here, whereby each rectangular box is multiplied by 2 because you have 2 decisions for each of these cases. And because you have these 2 decisions, by cross-variable equality constraints, you can even identify this direct link from investment costs to cooperation, and that would, I think, make your argument, your hypothesis tests, in a way, a bit more convincing than they are now. Okay, so long story short, subgame choice and the choice to cooperate should be analyzed simultaneously, and this potential superiousness between the 2 should be addressed in the analysis, and it is possible to address this with an instrumental variable setup. Finally, by the way, because you have individual level data, you can include all these error covariances, correlations in the model. I would be happy to talk with you about all these statistical details afterwards if you want. Okay, and I have a number of minor points. I don't know if, I think I still have some time, so I can mention these minor points, which would be very easy to address by just adjusting the text. In the introduction, you bring up the online market exchange discussion for a paragraph or 2, and there you name drop a couple of online platforms. And that section I thought was needed to be a bit better developed, okay? So there was no reference there, there was no clear theoretical justification. The link between these online platforms and your design wasn't clear, so that you mentioned different platforms. How do these different online platforms relate to your experimental or theoretical design? Which aspects of these online platforms make it relevant for your study was missing. It would be immensely helpful if there was a figure that showed all this complex, full stage game, the gamma, as you describe, plots this gamma. Such a figure would be very helpful, First one-shot PD versus repeated PD, then under each these sub-games you have the other games, etc. That would be very helpful. There was some strange involuntary matching issue. So if there was an even number of subjects who choose the one-shot game versus the repeated game, then you force the subject to play one or the other game just to balance out, even out the number of people who made the same decision. And that could be something that you could exploit as a kind of instrument, Do people who are forced to play the one-shot PD behave differently than those who self-select to play the one-shot PD? Okay, that could be an interesting thing to look at. Seeing 62% of your subject pool being internationals I was really happy to see this when I was in Utrecht. As far as I remember, we didn't have so many internationals in our subject pool, which was something I was happy to see. You say the average profit was 16.6 euros. That's good, especially now with the currency exchange to British pounds, but it would be good to show also the minimum and the maximum, the range. You also say the models with different groups of control variables in your robustness checks, you run them separately for different blocks of control variables. It wasn't clear why. Why didn't you run all of them together? And you make the point that you explore the limits of rational choice approach. And I thought this was a bit, could be over the top, a bit overselling. And as I say, evil reviewers would pick on these kind of points because, as I say, there are better ways, more systematic ways of doing this. And I would refrain from making these kind of claims when they're not fully backed by the analysis. So these were my minor points. As I said, this paper is already rather well developed, and hopefully addressing these points will make it even more suited for publication. Thank you very much.